Hello everyone, I hope you are doing well. In the previous video, we learned about built-in function. We learned more than 40 of them. I hope you understood all the concept properly. You need to know most of them, okay, since we'll be using them again and again here. So I won't be coming back. So please go through it one by one. If you're facing any difficulties, please comment down. I'll try to solve them. Today we'll be learning a little bit more extension of Python function. That is, we'll be learning about Lambda, generators and decorator. These are also some extension of Python function, okay. We'll learn one by one all of them, then you'll understand them clearly. First we'll go through lambda function. So if you go by definition, right, then lambda function is a small anonymous function defined using lambda keyword. So here three keywords are very useful, so that you know whenever you talk of lambda, just remember that there are three keywords. One is that it's small, second is anonymous, and the third is lambda keyword. Okay, so when we'll go through example, you'll understand this. Just I want to say that it's anonymous means it does not have any definition. Like when we define a function, right, we write def, then the function name. You don't have to do that way, but you have to be careful because you know there is also one more keyword called small. When we'll go through an example, then see how it's defined. Okay, first let me define one function called isEven. Okay, define isEven, and it takes a number and returns you if it's even or no. And you know, to return that, what you can do, you can modulus of 2. If it's equals to 0, then it's even, right? So this is a small function, and in the previous class we have learned about filter, right? So how filter works is, suppose if it takes a list, suppose this is list 1 and this is some number like 1 2 3 4 5 6 7 8 9 and 10. So if this is a list and you want to filter only the even part, how we used to do it, we were writing like this, right? Print, we used to put it under list, call the filter and put a function here like isEven and put the list 1. Now if you run this, we'll be getting all the even number, right? This we have learned in the previous class. So if you don't know what filter is, please watch the previous class. Here we have talked in depth about how filter works and what even is. So here if you see, this even function is too small, right? It's just one line of code. So to look over all these small functions, right, that is how we use lambda function. And how lambda function is, let me comment this out, and just under this let me put a function. Suppose this is one more function called even. How you define is, you write lambda, lambda, put the argument that you want. Here you want number, right? So you write here the variable name num, then you put a colon, then here you write the expression that is to be returned. Like here num percentage, right? Just copy this and put it here. So this is how you define a lambda function. So let me write here how it's defined. First is the keyword lambda. Okay, first a keyword, then the variable. This variable can be one or more. Okay, just put a comma, and if you want more, put here. Put the colon. Colon means the variable is done. Now what is the operation I need to do on this variable? Then here the expression. This is how a lambda function is defined. Okay, lambda. So you put the variable, then you put the expression what is to be calculated. Now this function, right, this one, this line and this function is the same thing. Now how can you verify it? Okay, let's verify once. Let's print isEven. This is the function, right, in the previous one when we defined as def, and write 2. You know 2 is even. Now let's run this. See, you gets true, right? You should be getting true because 2 is even. Now if you do the same thing, don't run with isEven but run with even, this one, right, it looks like a variable, right? But here you need to pass one argument. Okay, let's do one thing. Let's call this even directly. Let me comment this out and call this even. What does it say? It says it's a function of lambda. Now since it's a function, you need to pass argument. And what are the argument? You need to pass this one, right? These are the variables. So how many variables are there? You need to pass that many only. If you call this without passing anything and run this once again, see, it says lambda missing one required position argument num. Now let's pass here 2. Now if you run this, see, this also returns 2. That means this lambda function and this function is same. And why it was called anonymous is, see, here we did not write this define, and we did not put the function name and put the parameter like this, right? It's just one line, and that is where the small comes. The expression is to be small. Okay, it's not like you can't perform larger thing. You can put if else condition and all that, but lambda function is not the drop-in replacement for what function is. Lambda function was introduced so that just when you want a small concise function that has very little purpose to accomplish, okay, that is how you use lambda function, and it becomes more useful when you use some function like filter, map. So let me show you in filter how you can do this. So in this filter function, right, let me copy this, do it here so that you know that how you can use both of them. Here, instead of calling this function, what if you write this lambda function here itself? So you can write here itself, you can write lambda, put the number and just say number %2 equals to 0. Now what this will, now you don't have to call this function. Okay, now this one, right, this anonymous function will take care of like what to be done. So from this list, it calls a function, so it will be calling this function now, and what it will do, it will pass the number in here, and this number will be checked on this condition. If it returns true, it will come in the filter. If you run this, see, you'll be getting the same thing. You got the event, right? So that is how lambda works. So if we come to basics, what is lambda? So it is not defined, it does not use the DEF and the naming system of how function is defined. It's an anonymous function, it does not have any name of itself. Here we are assigning to a variable, but if you see where the expression is, right, it does not have any name of it. And how it is defined, you put the variable after the keyword called lambda, put a colon, and in the right hand side of the colon is the expression that you want to compute based on this variable. So what are the variable? You can put multiple variable, okay, you can put comma and put another variable also here, and you can use that variable to perform some actions. But be careful when using lambda. Lambda was not a drop-in replacement for function. That is, whatever you can do in function, you can do with lambda most of the things, but that is not the purpose of lambda. Lambda was introduced just to do small tasks like getting the even number, and sometimes if you want to do the square of a number, like let's do the example of filter. So you know how filter works. In the last class we learned about filter. So the map, so what you do, it calls a function. Here let's put a lambda function, and let's say whatever the numbers come, just square it. So how do you square it? You just multiply by 2 or put a square here like this. Okay, then this is this. Now you put the list. Now if you run this should give you a map function of it. It should not give you the list. Why? Because map does not return you a list. It returns a map function of itself, map object of itself. To make it list, you need to wrap over them with a list. So you put a list wrapper inside it and run this. See, you'll be getting the square of this. So if you are using lambda, most probably you'll be using when using filter, map, or some other functionality when it's a small purpose. See, the purpose is very small. You just need to square them. So, but earlier what we did in previous class, we defined one more function called square, then we put the here. But you see, this is just a wasting of 2 lines of space, right? And you will not need this in the later part of your script. So if you think you just need it once or twice of things, and it's a simple lambda function can handle it, like you don't have to put so many expression in it. Just you take a variable, perform a small operation in it and return, then you can use this lambda function. So this is all about lambda function. I hope you understood how to define it. Make some more function using lambda function. Do some small thing. Try to do a bigger thing also, but it's recommended to not try anything more than expression, simple expression using a lambda function. If you want, just define it using the function keyword. Okay, that is how lambda function works. I hope you understood that. Now let's go to the second function that we'll learn today, that is generators. So for generator, right, if you go by definition, you can see it's a special type of function that allows you to create iterators in a more memory efficient and lazy evaluation manner. So what does this mean is, so in a function, right, when we wanted to get a long list or something, and we need to calculate it, so if the list is too long, like you have millions of numbers, it will take so much of time, right? But what if you could do that without using so much of time at of starting itself? We'll just divide it in the shorter timestamp and we'll get one by one when we need them. So that's the main purpose of generator. Let me show you an example, then you'll understand. So suppose we have a function, okay, def, and it's called return number. And what it does is it takes a number, and whatever you every time, right, it will keep a long list of a number. Okay, suppose it's a list 1 equals to empty list, and it keeps appending while number is less than 1 million, 1 million or something, put how many zeros you want, and you keep appending it in a list. Okay, then you keep list1 dot append and you put the number in it, and what you do, you increase the number by 1. Okay, now what this will do is, whenever you call this return number, right, whatever number you pass, this number, we have already learned how while loop works. This number as how much, so what is the number is ones, tens, 100, 1000, 10,000, lakhs, 10 lakhs, crore, and crores. So it's 10 crores means it's almost is it 100 million, yeah, something like that. So until it goes there, it will keep on looping one by one, because we said every time this while loop run, increase by 1, and it will keep putting this in a list. Okay, and at the end we want to return this number, you need to return this list. So what do you think, how much time will this take? This will take a lot of time, right? So if you wanted to see how much long it takes, let's do print return number and put a number 0. Now if you run this, see it's waiting. Okay, if you see this side, it's waiting. I won't go forward, we'll just be waiting to see how much time this takes, just to get the list of this. Okay, just to get the list of this number. You see I'm still waiting. So the calculation is not getting completed, though it's running very fast. Okay, this program runs very fast. This doing 1 million tasks is not a very hard thing. So it will just go through this number 1 plus 1, it will keep on increasing, it will keep on appending in this list, it will just keep on going forward, and whenever this condition is wrong, then this return statement will be coming. So let's see how long it takes. Now see, it's getting printed now. Since we returned a list, right, this whole list needs to get printed. So it will just keep printing. Let's wait till it finishes. Okay, it should take a lot of time. Let me cancel this, and we cancel this by pressing Ctrl C. Okay, you see I did Ctrl C, that's why this ended. Now you see what is the problem here, right? So you call a function that has 10 million things to do, and if you do it this way, it will take a lot of time. So you know, since it's running one by one, right? So for completing this function, it will take suppose 10 minutes. Now you have, suppose you have one more function here. One more function here, return number 2. It does the same thing. It does the same thing. So it is 10 plus 10, 20 minutes. Already 20 minutes gone. You have to perform so many things. So to overcome this, what you can do, you can use a different type of function that is called generator. So how generator works is, so suppose we have the same number. Okay, so return number. Now this is generator. Now suppose we take a number. How this works is, do the same thing. While number is less than whatever you want, just put the same thing. Put the condition also, like it needs to increase by 1 by 1. And instead what you do, you don't add a new list like how you did here, right? You don't add a list, but here you add one return statement. This is not return. Okay, how you use return, just use this keyword called yield and put the number here. See, so this is the keyword. Okay, the main keyword that is different from function and generator is this yield keyword. In general function, you use the return keyword, but for generator uses the keyword yield. So what this will do, this won't return you the complete list here, but this will return you just a one computation of it. So if you want more, you can just loop over them and do the computation again. So now if you run this, okay, see both of these are same thing. I'll show you how it is same. Now if you run this, okay, now if you print this, this should not return you a number. Return number. Now if you run this, let's not run this because this will take a lot of time. See, it will return you a function return gen. So it's returning you a function, but it's not returning the list. Then you may be thinking like, how is it similar? Here we are getting a long list of all the numbers, but here we are not. So what you can do here is, let's put the number. Okay, we forgot to put the number here and run this once again. See, you get a generator object, right? Here we are getting the list because we returned the list. Here we are getting generator object. And how is it similar is like this generator object, like you can loop over it. this will form like a list. If you go in a for loop, right, you can do for I in this function. Now if you run this, print I, if I is equals to 100, let's break it when it's 100, okay, since we don't want to go up to 10 million for now, and run this. See, we get up to 100. This will have all the 10 million things. But what it does, it does not run in the starting itself. When you call this function, right, it does not complete its complete cycle of running up to 10 million. What it will do is, it will go for the first number, it will yield this, then it will stop performing its thing. Next time when you call the next time when you call this, right, since in a for loop you'll be calling the next of it, right, when you call the next of it, then the next thing will get produced. So we have learned about the next function, right? You can use the next function here also. Let's say this is the function, right? This is a generator function. Let's put this in a variable. So we'll call it gen function, okay, and put this here. Now what you can do, you can use the next function here, next of gen function. If you run this, you should be getting 0. See, you get the 0. So how this works is, this is similar to how iterators work, right? This is returning an iterator basically. So it is not returning in the whole list, but it's returning an iterator, and you'll have access to all the elements that you'll have access here. But there is one difference here. So in this function, right, here this is a list. So if you write here, this returns list, right? This returns list. So you know, in list you can have index, right? So you can do something like called print lst of suppose 0. This is valid, right? But here you can't use this index. Cannot use index because this is not returning you a list, but it's returning in iterators for you. So you can use the next function to get the next thing, but you can't use indexing here. So this is one drawback of the generator, right? So this is how generator works, other than from general function. What is the best use case? Best use case when the task is very long. The task involves a long list or long processing. So it's better to break into chunks. Here how the chunks happen, right? It will give you the first computation value here. Then when you do the next function, right, it will give the next value. And if you wanted to do in a for loop, since you know when we run this, right, it will convert into iteration, and it will go next in this for loop. And when it means stop iteration, then this iteration will break. So this becomes if you go to a definition also, right, it says it's more memory efficient. Why is more memory efficient? Because it's not forming a long list of these 10 million numbers, right? It is just forming one object that has reference to the next, and it know what computation to be done. And it's lazy evaluation. Why it's called lazy evaluation is because we are not doing the complete evaluation as one instance. We are doing this whenever you want them, whenever you are calling them. So this is what generator function does. So you can use them when you are returning a long list or you are reading a long file. When we'll do file, right, we'll use the generator. You'll understand this more there, because when you read suppose you are reading a book, right, a book will have thousands, millions of lines. If you do using this general function, you want to list all the lines, right, then you have to go one by one through all the lines. But if you do using generator, you go to the first line only, you print the first line. You want the second line, just do next, you'll get the next line. Keep on doing next and you'll get the next line. Or use a for loop, and whenever you meet the certain line you want, just break it and you'll be getting that thing. So that is how generators become useful. It's like when you're using too long a list, or you're doing a too long sequence computation, and you don't want to do all at the same time, but you just want to have it. So whenever you need it, you can just use this next or for loop to get to your respective part of it. That is how generator works. It's very useful. I think the best case comes when we do in the file reading, when the files are too long, when to read line by line. The second best case is this one, right, the example that we showed. Now here we want to read all the numbers, so it's better to use generators, because using generator we are not computing the whole thing, but you are computing just one object of it, and we get access to the next function. So whenever if you want to do the second one, go to the second using the next, or put it inside a loop, and you will get access to everything one by one, and it does not have to wait for computation. The computation is in one at a time, whichever you want it. So it's on the fly, okay. So that's why when we run this, right, we directly print out. But when we did for this, right, we are waiting for this computation to be completed. So this is all about generators. I hope you understood this. If you are facing any difficulty, please comment out and try to do something like put this millions, do something else, and see when computation take long using this list method. But using this, it will not take much of time. When we learn about files handling, right, then we'll come to this once again, okay? And there you'll understand more why we actually need it in a real hand, why you actually use it in Python. Okay, this case may not be coming every time because we don't do something like this where we want million of numbers to be printed or even a list. But yeah, it's good for explaining like why we want generators. So this was all about generators. Let me comment this all out. I hope you got this. Okay, if you have difficulties any of the lines, right, just comment out in the below and I'll try to solve it. Moreover, I'm creating a Telegram group link, okay, so that if you have any problem you can post it, like put the screenshot or anything there, and I'll try to solve it. I'll list the group link in below in the comments, in the description. You can take it from there. Okay, then come our last function that we want to discuss for today is called decorators. It's very important, okay, when you deal with frameworks like Django and all that, right? When you for creating websites and all that we'll do in the later part, decorators will become very useful. It will be using some decorators, not now, after when we go to classes and all that we'll be using them, and that the decorators will be very useful, so it's good to learn it. So now we'll be discussing what decorators are. Okay, so if you go by definition to what decorator is, right, so decorator is a special type of function to modify an existing function or method without changing its source code. What does it mean? Like suppose we have a function that adds a number, right, but we wanted that before adding some number it should say that we are adding a number, and after adding it should say that this is the result. And we want to do the same thing for subtraction also. Then we'll start repeating our code, right? So let me give an example. Okay, suppose this is definition of add. What it does, it takes two number, num1, num2, and it returns num1 plus num2. I'll explain it why we need it and at the same time what it is. Okay, so still we are not defining decorators yet, but I'll say how it's defined. So this is one, okay, and let's do one more that takes subtraction. Okay, that takes one more called subtraction, that sub, and it takes num1 minus num2. Now suppose you wanted to say whenever you call this, right, it should print something called here like print starting the function, starting add. Okay, then in here it should say result after computation, right? Suppose this is the, let's say here the result is this one, then it should say print the result is, and put the result here, something like this. Okay, and you want to return the result. Now you want to do the same thing for subtraction also, then you have to again copy this and put it here, right? So what you can do, you can use decorators. What decorators is like, it will modify this function. It won't change what this function is trying to do or what it's doing, right? Okay, it won't change any of this, but it will add some more customization to this function itself. So how do we do that? So for doing that, you need to define one more function. That function is what that will change the behavior of this function. How you can define? You can define a function, let's call it anything. Let's suppose we want to log. Okay, since we want to say print statement, suppose it's called log, so you can say log. Here log needs to take one, suppose because we will be using above the function, it will modify a function, then this log has to take a function. Okay, inside this definition we need to define one more function. Why? Because that is the function that will do all the computation and all the changes in it. So mostly you can call anything, but it's definitely called a wrapper. Because why? Because we are wrapping a function, and inside the wrapper we pass the arg arguments and the keyword argument. We have already learned what arg and keyword arguments is. Since we don't know, right, like how many parameters this function will take, so we pass this because this will give us a guarantee that whatever they pass will never fail for this. And here what you can do, you can call this function, the function that this log is taking, right, this function, you can just call this. You can call this function, pass the argument and keyword argument. If you're not understanding, let me complete it, then you'll understand it better. Pass this, put in a result, and return the result. Finally what you need to do, since after this function is completed, right, then you need to return this function itself. return wrapper. So that is how you create a decorator. So how it is, first you need to create a function. Inside the function you need to create one more function that will do all the computation, all the changes you wanted to do, right? Then you can do here. Inside this func, right, this is the function add subtract that you wanted to change, right? This will be the function that is getting called, and these arguments are any argument that will be coming here num1 num2, this will be passed here. A similar thing will be passed inside this func. Here this func is the add or subtract that we wanted to do, okay? And finally we'll get the result and we'll return this result. After the computation of this wrapper, we need to return this new wrapper also. So that is how decorator is. And to use decorator, we use the add symbol. Now suppose if you add here add the rate, right, and you put the log, what this will do, before running this add function, right, it will call this log, and inside this log this add function will run. How? When you call this log, it will call this ref wrapper by itself, then it will call this function, and here this function is the add function. So when you call this log, right, this add will be sent as function here, and here you are calling this function, that means you are calling the add. Whatever the result is, you are calling the result. Let's run this add and see if it works. Let's print this add 2 3, okay, and let's run this. See, you still get 5, though we added this, right, at the rate log. Let me bring it closer. Though we are at the rate log, but still it gives you 5, right? So how does this work? So what you can do now, let's say now you want to write something before the computation. What you can do, you can write something like print calling log. Now if you run this, see, you'll be calling log. Why? Because this is working as a decorator. It's adding more function to this add. So now you're not directly going to this add function. What you're doing, first you are calling this log, that means it will call this function. Inside this function there is a func, this keyword, right? You can change it to anything. The func is the add. This add will get passed here. Then we define one more function wrapper that will do all the computation or the changes that we wanted to do. We name it wrapper. You can name it anything whatever you like. Here we pass the args and keywords. Why? You can pass the variable name also, okay, num1 num2, if you know that is what that will get passed. But here we pass this too because we don't know what are the variables that are coming. Since we don't know, that's why you pass args and keywords, so that if anything comes, we don't face any problem, everything works as it is. Then inside this function is all the computation, like we are calling this print log. So whenever you use this decorator log, right, this line will always get printed. Then what we do, then we finally call the function that calls this one, right? We pass here func. This func is the add, right? You know that. Now we'll call this function and we'll pass the argument and key argument, because we know here some arguments will be coming from the function because it calls log. We call this. Now this will ultimately call this function, and what this function will do, it will create a sum of it will return, and whatever is returned is passed into this result, right? And this result we finally return the result. So this is getting written and you finally print this 5. So that is how a decorator works. So let me put a comment here. How it works is, first you define a function. Define a function and pass the function as an argument. Okay. So pass the function as an argument. So here what is the function? What is the argument? Here log is the function, func is the argument. Okay, I have got this. Here log is the function, this is the function, right? And func is the argument. So here func is the function which will get modified. So here this func, right, this is this add or subtract, wherever we call this, this is what that will get modified. Okay, then we define a wrapper function that will have all the modification inside the function. Here log. So here inside this log, right, you need to define one more function. This is what will do all the computation or all the changes that you wanted that other function should have, right? You can do it here. And finally finally return the wrapper function. So if you see, after this is completely done, right, then you return the wrapper function. So these are the 4 steps you need to keep in mind when you're working with decorators. First, you define a function, you pass an argument. Here the argument will be the function that will get modified. Then you declare one more function inside the function that will have all the changes that you wanted this function should have, and finally you return that function. Now suppose if you pass this log to this sub, right, this will also work same way how the previous one was working. If you comment this out, now if you run this, see, it still is calling log. Why? Because we are using the same decorator, right? So it will always enter this line and it will do computation, it will return the result. So that is how you can do. Now we did in the previous, right? Now you can do here also. You can do print after computation the result, and you can put the result here. Put an f string. Now if you run this, see, it says calling log, then into after computation of result, then it put -1. Why? Because since you are printing, right, that's why it's printing the -1 also here and it's calling there. These 2 lines are coming from decorators. These are all the update we made. It's calling before the function and after the function. So if you want to do anything before and after the function, suppose you have so many of them and you wanted to print some log like what we are doing, right, then you can do before and after. If you want to get access to what is the function that is called, right, suppose this is a function, what is the name of this, you can just simply like calling log for, to name it, it's like func dot _name . Now if you put in a curly braces, put an f here, right, and run this, see, you'll say calling log for sub, because sub is the function name we are calling, right. So this is how decorator works. If you wanted to perform any action before a function, like if you wanted to print something or do some calculation even before the function is passed, you can use this keyword args and keyword args. So let's print this args kwargs, so that you know that we have access to everything. See, you have access to 2 and 3, right, and if you pass anything by the name, if you pass a dictionary, then the dictionary will be coming here. So we have access to all the number, and if you wanted to do anything, you can do with this value here and change the value also. Okay, that is how this works. I hope you understood how decorator works. So decorators are a way of modifying a function. Suppose if you wanted to do some computation before this function is run, then you can do using this. You do something. This is where actually the function, this is where the actual function run. Okay, this is where the actual function runs. So this is where the actual function runs. These are the modification that we're doing before. So this is called before. Okay, before function call, then this is the function call, and this is the after function call. So now you have access to all of them. You have access to when the function call will happen, what will happen before, what will happen after. So if you want to do any modification, you can directly do it here. So that is how a decorator works. I hope you got the concept. So to define this, what you define a function, pass a fu, we write func, you can write anything here. Okay, this is just the name you are giving to that function that will get passed to this decorator. And how to use decorator, you can use the @ symbol. So to use the decorator, use symbol above the original function, symbol followed by decorator function name above the original function. I hope you got this. So look at this line and see if you can create some more decorators where you can do something before the computation is done, after the computation is done. Here the naming are just, I named it so that it looks clear like what it is called. By definition, these are called wrapper. Okay, that's why I kept the name as wrapper, but you can put anything here. Here log, here we are keeping the name as log because we wanted to know what this decorator does. It's a logging function, right? So that's why we keep here log. You can name it anything you want, and you need to finally return the wrapper function. Okay, so for this to work, you need to return the wrapper function. So that is how a decorator works. I have understood this. Create some more decorators for all the function that we learned till today, right? Create some decorators and post in the group, in the Telegram group that I'll share below, right? Post it there and see if it's working. If you're facing any difficulty, take a screenshot and post it there, and I'll try to solve that also. So that was it about decorator. So these are the three topics that I wanted to go over for today. That is lambda function, generator, and decorators. I hope you got the concept clearly. Decorator will be learning about this later in the classes. Mostly we'll be learning on classes because classes have many decorators of itself. But in the next class, when we'll learn about import, right, there also we'll use some decorators. I'll use something called LRU cache. Next class also, right, when we'll be using import, I'll use one decorator here called LRU cache. We'll be looking at time and all that. There also one more time I'll go through decorator once again when we learn about import. So I hope you understood this, and if you're facing any difficulties, please comment out and I'll try to solve each on them. So yeah, now let's see what are the changes we did and push it to GitHub. Git status. Okay, this is a change. Git add all. Git commit lambda generators. What is the one last thing we learned? We learned about decorators. Okay, now let's push this. Git push origin main. Okay, now if you go to this website, you can see all the changes reflecting. Let's see. If you go, yes, on the lecture number 12, right, so there's the 12th lecture. So you can see we have lambda function. Okay, there is a lot of gap in the middle. We have the generators, and finally we have the decorators. I hope you will understand all the concept by looking at this example and watching the videos simultaneously. But if you're facing any difficulties, you can comment out or join a group on Telegram and post your screenshot or any difficulty that you're facing, and I'll try to solve them. Okay, I think that was it for today. Yeah, that was it for today. Thank you for watching. See you in the next.